Hi, my name is Alex Williams, founder of the NewStack, and you are listening to the NewStack Analyst Podcast. We look at application development and management at scale. IBM is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about IBM's perspectives on these timely and important topics in our latest ebook about networking, security, and storage. It's available for download at thenewstack.io. Now let's get to the show. All right. Hey, Jason, how are you?
I'm good. How are you?
Here with Jason McGee of IBM. And Jason and I have actually been doing almost like a series of interviews, I think, over the past several months.
Every time we get a chance to get together.
And the last time we talked about identity issues, and what you were talking about was Docker and how it kind of spans developers and operations. Right?
Sure.
And we're here at DockerCon for in Seattle, and they actually made a point of saying, who's a developer here, or who's an operations person here, which is something you wouldn't have heard of them really say at the last DockerCon.
Yeah, I think you're right. No, I agree with you. It seems like they've kind of added that into their language.
Yeah. I guess that speaks to kind of why we're talking about networking in some respects, doesn't it?
Mm-hmm.
And there was, and this is just a hook for kind of this interview is going to be published later, but it seems like a hook for discussing where things are in the networking and security and storage world right now. Because what Docker talked about is essentially kind of like baking in that orchestration, right? Are we starting to see baking in of networking capabilities too? Is that something we're seeing?
I think you're going to see the baking in, at least, of the orchestration of the networking capabilities, of the setup and configuration of the network. The core network itself, I think, is much harder to bake in. And even some of the things that we saw today with some of the swarm mode kind of network overlay capabilities, I think those are very interesting for developers. I think as you look at production workloads and you look at running containers in cloud or on-premise production environments, those networking capabilities have to integrate more deeply with the core network. And so I certainly think there's a desire in the container world to get developers to have an easy way to specify the networking capabilities that they need. But I think a lot of that's going to have to delegate down onto the underlying networking fabrics to be able to operate at scale and to operate efficiently and to have the right kind of security constraints.
So let's talk about the baking in of the orchestration itself. How does that affect the networking?
Well, it affects the networking, I think, in a couple ways. One is any abstraction that gets introduced, by definition, kind of limits what you can do with the network. It has a particular model about how, what capabilities the network exposes and how the network exposes those capabilities. I think if you look, for example, at the difference between libnetwork and Docker and Neutron and OpenStack, you see that difference. Neutron has a very flexible API that allows you to configure networks, configure routes between networks, and configure all the settings about how those networks operate. And you look at libnetwork, and you have this very kind of application-centric, very simple kind of application-centric model for the network. It's easier to consume, but it doesn't necessarily give you the richness. And I think the challenge is how do you bridge those two worlds?
Yeah.
Right? And that's really the challenge, is how do you keep the simplicity of an application-oriented networking abstraction while still connecting into those underlying deeper networking concepts? Because I can tell you, from my experience working with customers who are going to production with containers, and go spend an afternoon with a CISO about how the network works and how endpoints expose themselves on the network and how you're doing IPS and intrusion detection and firewalling. And those are hard problems. They're really important to get right for running production workloads. They don't lend themselves well to a simplistic kind of application abstraction. So you got to figure out how to blend those two together. And I think you're starting to see some of that. I'm encouraged by projects like Courier on the OpenStack side that kind of link the libnetwork abstraction to the Neutron abstraction, so you can kind of have both, if you will, create the network maybe if you need to in Neutron and then use it from Docker. I think some of those models will emerge as more relevant in kind of production workloads around containers.
So spending an afternoon with a CISO, and when you talk to them about things being easy to consume, they're dealing with all those networking complexities that that you speak of. Where does that make for deeper requirements to better understand when you're trying to think of an easy to consume environment, kind of with the more this world that the CISO kind of sits in on a day to day?
Well, I think you see, I saw that even today in the keynote. You mentioned the fact that Docker brought up dev and ops, and I think the more everyone, I think containers over the last year or two have certainly transitioned from kind of a developer-centric tool and are moving their way rapidly into production settings. Lots of people are in production, but as kind of the mass of the community is starting to really start to go to production with containers, all these kinds of concerns start coming to the fore. Right. How do I deal with security of the network? How do I deal with encryption and security in the application? How do I ensure that I have control over the pipeline of how that application rolls into production? How do I connect it to my logging and monitoring and alerting tools? All of those kinds of, the typical problems. None of that's new, right? Every new technology at some point has to mature and solve all of those lifecycle problems around the core application. And I just see that happening now with Docker, and you see it, some of it's happening in core Docker, and some of it's happening in the ecosystem of tools that are emerging around Docker, right? And networking is just an example of that to me. It's a particularly nasty example sometimes. Networking is a hard problem to get right and to do at scale and to do securely, but it's fundamentally the same problem of how do you mature into a production capability around containers.
IBM puts a lot of investment into open source ecosystems,
yes.
and you're very involved in the Cloud Native Computing Foundation and OCI. OpenStack, you name it.
Right.
So where does the onus on IBM's part seem to focus now? Does it are you focusing on, in terms of the open source ecosystems and thinking about these complexities with networking?
One of our big focus areas right now is how do we actually bring some of these communities together. If you look at our cloud platform that we're building, we have OpenStack at the base. We have containers with Docker and Cloud Foundry. We have event-oriented program with Whisk. We have this kind of big stack at multiple layers within cloud. And what's important to us is how do you actually bring those things together and have them actually work together. Communities sometimes are messy places. They're full of people, and people make decisions about how to evolve for lots of reasons. And what we've really tried to do is figure out how to start to bring these together. So networking with Neutron and Courier and LibNetwork and CNI out of the Cloud Native Computing Foundation, that's a complex space. I would love for it to be simpler. We've been, working within the community, running experiments, getting real data to help drive people towards some more common models, to see if we can collapse some of the complexity out of the system. And we're doing that with Cloud Foundry. Trying to figure out how does Cloud Foundry and the container ecosystem play together better, and what are some of the unique capabilities that we could reuse across the platform. So, besides evolving the core technologies in open source, our other big focus is this whole idea of how do we actually get them to come together into a single stack.
Okay, so you're trying to bring it together. How are you trying to do that?
The first and I think most powerful way that we're trying to do that is we're building a world-class public cloud platform on these technologies. And from building that platform, we gain real-world experience on how those technologies work in production, what the user experience is around those technologies, where the rough edges are, and where the integration points are. And we're taking that real experience and we're pushing it back into those communities. We have committers and maintainers on all those projects. We have influence through our contributions over many of those projects, and we use that experience to help drive the roadmaps on those projects. Right? To me, that's the best way to bring things together, is to do it based on real data and real experience. And so, that to me is the primary way. It's not a theoretical integration. It's, hey, we have this real problem. We need these things to work together. Right? Drive that.
So you were talking earlier about how you bring it together, kind of, and I'm curious on And you talked about the complexities. What are some of, the people are an obvious complexity. What is making it complex now? I guess it's just in the complexity of trying to bring different open source organizations together. Is it an organizational issue or is it a technical issue? Or is it both?
It's both. There's always kind of organizational issues on who, what problems each community thinks they're trying to solve and who they want to build dependencies on. Some of solving these problems is about building dependencies between communities, and that takes thought and time, and there's always some resistance sometimes to building dependencies between communities. It's also technical, people have different perspectives. Look at the container space. Look at networking with libnetwork in Docker versus CNI in CNCF. They are on one level fundamentally doing the same things, but the people kind of driving those to abstractions have a different perspective on what the network should do and how you should expose it. So they have a different philosophy about how to expose a network, and getting past that philosophy. That philosophy manifests itself in real technology choices. It manifests itself in API design, and getting past that and saying, oh, well, these things aren't really that different. Can we bring this together with that or layer them in this way? That just takes time and effort.
I guess an example of that is the lack of true support for libnetworks in Kubernetes.
Right, exactly. That's a good example, right? So that community has chosen that the CNI abstraction is closer to what they think is the ideal abstraction. They've chosen to use that. Docker believes in libnetwork, so they've used libnetwork. So you have these two, big container communities that have a fundamentally different philosophy about how to expose the network.
What happens in that gap? So you have these two communities. What is the gap? What's instead of what's causing the gap, what are, some of the technical gaps that result from that?
I don't know if there's technical gaps as much as
integration gaps.
Yeah, it's just integration challenges. So it introduces complexity in the platforms. If you think about, one of the maybe perspectives that IBM often brings to the table is that customers have a diverse environment. They're not going to be all Docker. They're not going to be all Kubernetes. They're not going to be all OpenStack. They're not going to be all of anything. And most applications have to mix or integrate these technologies together, right? And so within the confines, I think, of a given space, like within Kubernetes, the fact that it has a different abstraction than libnetwork doesn't matter. Like, it works within the Kubernetes space. But now go build me an application that has something running in Kubernetes and something running on Swarm, or something running on Swarm and something running in a VM on OpenStack, and they have to talk to each other. Then all of a sudden, all of these assumptions and abstractions introduce complexity into your life, because now you got to figure out how to connect stuff together. Right? Like, if I have, if you take the Swarm mode stuff, in Swarm mode this morning, I talked about this overlay network that's being created automatically amongst all the Docker hosts. Well, what happens when that network needs to talk to something outside that network? And what if that connection needs to be a private connection, not over a public internet address, but
isn't
over
that
a
a
private
plugin
network
then?
Connection?
Or no?
No, sometimes it's not, because they have fundamentally different networking control planes. And so you wind up either popping out to public, which then you get a nice conversation with the CISO about how the traffic is going through public interfaces, or you have to build VPNs or tunnels. You get all these complex components that enter the picture to try to bridge these islands that have been created. And so I think sometimes the complexity comes from how things get used together, and that's hard in communities, because sometimes there's either a lack of understanding or motivation within the community to fix that problem, because they're like, well, within my space everything works great, and they don't want to deal with the complexity of how that space integrates with everything else. And as a full platform cloud provider, we have no choice but to figure those things out, right? Because I want to build a platform where my clients can mix different technologies as needed, depending what they're doing. If they're bringing an existing workload to cloud, running it in a VM makes a lot of sense. Just lift and shift that into cloud. If I'm building a new microservices application, I want to do that in Docker. And there's perfectly reasonable cases where those two things might need to talk to each other. And so I need a network substrate that can work between them.
Now let's take a quick break before we get back to the second half of the show. IBM is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about IBM's perspectives on these timely and important topics in our latest ebook about networking, security, and storage. It's available for download at thenewstack.io. Now let's get back to the show. This has a direct impact on, on how we think about hybrid architectures, doesn't it? Mm-hmm. Doesn't it affect the whole kind of concept of portability?
It does, absolutely. In fact, that's what I think you're seeing. I think you've seen that evolution happening or play out with containers very directly. Like, in the beginning, container portability seemed like, that was the solution. Like, I could build a Docker image and I could run that anywhere. But then you quickly realize that, well, my app is actually multiple containers working together, and my app is making networking assumptions, and my app is making storage assumptions. And unless you can also make all those things portable or abstracted in the right way, then as you move the application between environments, you have to fix up all those gaps. And so you see things like pod files and Docker Compose and now DAB files and other things emerging as additional abstractions to try to capture the real definition of the application and make it portable.
What does that mean then for this whole idea of a hybrid environment?
Well, I think it means a couple things. I mean, one is it means it's more complex than often people give it credit for. Yeah. Their definition of hybrid is I can run Docker here and Docker there, and that's fine for some scenarios, but for lots it's not sufficient.
Right.
It means that consistency of APIs across the environment is important. I think it also means, like, if you look at, like, one of the other trends I see happening in a lot of these communities is if you look at certification. The notion of certification is wrapped up in actually ensuring you're running exactly the same code. You have to run the implementation of the open source project. It's not an APIs or contracts-driven certification. It's an implementation-driven certification. And that gets quite hard as you get into more hybrid environments where I might need a different implementation of a networking API or a storage API as I move into a different environment. And so, like, API-based certification becomes, I think, more important than it's being given credit for right now, because I need that flexibility to adapt the implementation for the environment I'm running in.
So what does that mean, API-based certification?
So API-based certification means the open source project or community defines a well-formatted API specification for some function, like a networking interface or a compute abstraction. And then there's a test suite that tests against that API and looks at expected results coming from that API. And as long as you implement the contract and you respond properly to the test suite, then you're compatible with that specification or with that project. And you can have different implementations behind that API. Right?
Okay.
In the old world, 15, 20 years ago, it was spec-driven certification. We had, like, JE spec document that said how it should work. We had a test suite against the spec. Today's world, the equivalent of that spec document maybe is an API contract, like a Swagger file that says, here's the REST API for the service, and I need a test suite against that. There's a number of open source projects, including Docker and Cloud Foundry, who are, their certification idea is a little bit more, not only do you need to have the API, but you actually have to use the code from open source. You have to use the implementation that came from that project. And that, I think, limits sometimes the flexibility that's needed to deal with the diversity of a hybrid environment.
How so?
Because then the implementation only takes care of whatever the community has thought of so far. So if I need to do optimization based on hardware or different backends for different networks or storage, then that can, in some cases, become hard because I need to replace pieces of the implementation. Or if I'm building, like, if you look at the challenge that we have in IBM, we're trying to build a full cloud stack. I want container orchestration to share resources, let's say. Maybe I want to do Swarm and Kubernetes and Cloud Foundry, and they're all running containers, and I want to share hardware, right? But there are 3 different orchestration systems, and so I wind up with 3 different resource pools. Well, maybe I want to collapse those resource pools and have one orchestration layer that sits below all of them. Well, that requires me to plug into those stacks at a different place, and if you have implementation-driven certification, it can be hard to do that. Right? There's just a whole bunch of dimensions, I think, on this hybrid problem, that as you get closer to kind of production at scale, you have to start to come up with answers to these problems.
It puts into conversation this whole concept of an open hybrid cloud, which you guys are talking about.
Right.
Why do you guys talk about an open hybrid cloud?
I think we talk about it that way because we believe firmly that especially where it touches the user, whether that user is a developer or an operations person, where they're building assets in the cloud, those assets should be built on open technologies and open communities, so they have freedom of action. Like we don't want people, we don't believe that you win by locking people in based on having a proprietary API or interface. IBM, we have that heritage. We played that game for 50, 60 years, whatever. For the last 20 years, with Linux and Java and WebSphere, we learned a long time ago that the most productive way forward for us and for users is to have an open set of standards and specifications around the assets that people build and run. And cloud needs to play that game too. So as we look at building a cloud stack, we wanted that cloud stack to have that same open characteristic, right? Because it gives customers freedom. And it also helps with hybrid. I mean, if you think about, okay, I want a public and a private cloud environment. I want freedom of moving workloads back and forth. One prerequisite for that is a common set of APIs and capabilities across those environments. And open technologies help make that possible. I have a container service in Bluemix. That container service exposes Docker APIs. A developer could build a Docker app on their laptop. They could run that in Docker Data Center on their on-prem. They could take that same app and run it in Bluemix public. And everything will just work because we're built on the same open technology with the same API. And if I came up with a proprietary interface like some of my cloud competitors have, then as they moved into that public environment, they would have to change all their automation, change their CI/CD pipelines, potentially change their application because that environment might have provided different capabilities or concepts. And so we just think openness gives you that flexibility to mix and match and deal with the complexities of real scenarios.
So one of the ways that communities change is actually through the participation of the community itself. And the foundations do a good job of driving innovation. But where would you see these open source communities on the road to engaging more users in the community? Because one of the things you do see is there's a lot of people who are working very hard on the development of OpenStack or Cloud Foundry, but a lot of them are they're working with companies like IBM or Red Hat or HP or whatever.
Sure.
And it's increasingly kind of apparent that the users, the ones who are working, or the customers out there, would benefit greatly from participating.
Yeah, I certainly agree with that sentiment.
And I think it would drive, and I guess the question is, do you think that would drive the community forward, and what are some of the things you think need to be done to achieve
absolutely.
this?
I think it would drive the community forward. I think some communities are better than others. I think Docker's doing a reasonably good job at user involvement. I think Cloud Foundry is doing a good job at user involvement. It's interesting. You're right that a lot of communities are kind of vendor driven. Most of the big participants in the community are vendors of some form. I think the user thing is most interesting because it represents a change in mindset that the users our customers have to have around open technologies, that their involvement in the community is important. That as a vendor using open technology, I can't always do exactly what I want exactly when I want to do it, right? If IBM wants to make some change to Docker, we have ways of doing that through the community, through our participation in the community, but I can't just assign some developer to go do whatever I want one day. I mean, I could fork the code, but to stay in line, it requires participation. And sometimes customers don't quite understand that. And I've had, for example, a number of very specific conversations with customers where they wanted feature X or Y or us to solve some problem. And I've had to explicitly say, I understand the problem. We're working to solve that. We can't just go change it tomorrow. What you could do is join the community and make your voice heard and help people understand why that's an important capability for you as a business and participate in the community to help drive that. And that kind of participation, at minimum, helps with prioritization of activity within the communities. It helps ensure the communities are solving problems that actually clients actually have. But in a lot of cases, those clients can actually help do the work too and participate in those communities. So it's important. I think it's on the rise, but I think there's, as you stated, a lot of room for further involvement by users of technology versus vendors.
So just in conclusion, we've talked about the changing dynamics of networking. We've talked about open source communities. We haven't really talked a lot about storage and security, but I think it kind of falls underneath this umbrella of kind of the open source, focus that you guys take.
Yeah.
How do you characterize this idea of, we call it the new stack of networking, new stack of storage, the new stack of security. How do you see it, playing out right now, in the context of just, helping people trying to better understand, how things are changing. We're seeing a lot of kind of like traditional networking architecture, providers. We're seeing lots of users who are associated with those traditional networking providers, and then we're seeing the rise kind of like of the developer and the less educated person in the networking space, in the operation space, who are doing more like these network engineering kind of jobs. So, I'm just curious on where as a technologist, how you're seeing this, how you see this evolving right now. And what are some of the your thoughts on the subject?
So I think the networking and storage conversation is kind of a manifestation of a bigger trend that's been happening for a while, which is this kind of shift from infrastructure centric to application centric. And historically, there was an infrastructure team, and they controlled how the network was set up and how storage was set up and how compute was set up, and the applications were designed to fit into that environment. And what we've been seeing over a number of years, if I took that definition of the new stack and said, well, what is new about the new stack? I think the new part is that we're trying to flip the model and say, I can define an application. I can define that in a way that is simple and portable and describes all of the requirements of the application, and then I can inject that into the infrastructure and it knows how to run it. And I think container started that with the basic runtime constructs, and networking and storage are just like the next round of that. So you're seeing, I think, that shift. Now, in that shift of like, okay, now I have an application developer who's defining networking constructs, that's where that real challenge is, because you need a simple way to just define enough of the application's needs around network, but then it has to fit into an infrastructure. And there's all these other concerns that most developers don't even think about. They're not thinking about intrusion detection and packet inspection. They're not thinking about firewall rules. They're not thinking about all of that kind of security and compliance things that happen on networking. They're not thinking about QoS and what happens when you get contention, and what happens when some application consumes the whole pipe and takes everyone else down. There's all these deep networking, and you can do the same thing on storage, these kind of deep concerns. They don't go away magically because we've shifted to an application-centric view. So the challenge is, how do we build that simple abstraction and allow the operational expertise to be injected into that, and allow the guys who are network experts, instead of doing all the work, to create the policies and the configuration that get driven by the application layer so the right thing happens. And I still think we're figuring that out, to be honest. I don't think that's a solved problem on the whole.
Software.
It's just more software.
Well, Jason, thank you very much for taking some time to talk again. It's always interesting having conversation with you on these topics, so I appreciate your time.
Yeah, great to talk with you too.
IBM is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about IBM's perspectives on these timely and important topics in our latest ebook about networking, security, and storage. It's available for download at thenewstack.io. Audio editing and sound design for the New Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.